So in this presentation, I want to cover a couple of different ways to control the marble and a couple of different ways to have the camera follow or at least view our level. So currently I have this set up where I don't have any control system set up on the player just yet, so I can't control it. I've removed everything that I've previously done. I do have a simple state machine that I built that I've attached to my player object just to experiment with controlling the camera zoom. I'll demonstrate that a bit later, but I did want to leave this attached just to demonstrate the concept of being able to attach multiple state machines to an object to manage different sets of user input or manage different sets of data. It's often most appropriate to have multiple state machines on the same object, a lot of simple state machines that are creating complex action rather than having one big state machine that has to switch through different states and track a tons of different information. So if I look down here at the Playmaker editor window, I want to point out there's a couple of tabs up here. We have the select button, which based on whatever state machine, whatever object we're looking at through the state machine window, if we hit the select button, it'll just highlight that. We can lock this current window, and there's a drop-down menu here that shows the different state machines that are attached to the selected object. So I have my player object selected, and when I click on this drop-down menu, it shows that I have an FSM player zoom. I can choose to add another state machine, and once I do that, I have a blank state machine. If I click on that drop-down menu, now I have two different state machines. Once I start adding multiple state machines, or even if I'm adding individual state machines, it's a really good idea to go to the FSM tab and make sure that you're naming your state machines appropriately. I'm going to call this FSM player control. I like to leave the FSM on the front the front end of this thing just to ensure that when I come across a list, I know I'm looking at the state machines. So I'm looking at the player control, now I'm looking at the player zoom, I'll go back to player control. The drop-down menu to the left of that shows all the different objects inside this hierarchy that are currently using state machines. So I can use this list to select different objects and bring up the state machine. I can use this menu to choose different state machines if that object has multiple state machines. So I'll go back to the player and I'll make sure that I'm on the player control state machine. Now, with this player control, I'm just going to really quickly set up a real simple user input setup. I'm going to go to input and do a get vector axis just like we did in earlier demonstrations. I want to capture a vector 3 based on user input, so I'm going to create a player movement variable. I want to make sure that that is a vector 3, and I'll add that. I just want to point out it's a good idea to use this naming convention of always starting with a lowercase. I'm going to go back to my state, and I want to store the user input vector into this player movement. So if I wanted to, I could map this to a different plane, but currently it's using XZ. So Z forward in the background, forward, backward, X left and right. That's exactly what I want. I want to translate now that user input into a physics command. So I'm looking for physics, and I want to add force. So I'm going to add force to the owner of this object, the player. I want to add it based on this player movement vector 3 that we're capturing from the user input, and I want to do that every frame. Now I'm going to reorganize this so remember there's priority. Whatever happens in this list first, it's going to get the access vector and go down and then add force next. Now in this case, this would work regardless of which one's on top, but it's a good idea just to kind of prioritize the logic of your actions in your state machines as you're building these. Now, one other thing that I want to do is I have this multiplier value, and if you remember, that multiplier is the scale at which the user input, we capture the user input and multiply the user input, the value of the user input against this multiplier value. So this is effectively the amount of force that we'll end up using in this add force. And so if I hit the play button, if I leave that multiplier at 1, and I push this sphere around, we're actually operating with a force between 0 and 1 based on the user input. And that just won't do. So what I want to do is I want to bump up that multiplier value, but rather than hard coding something in here like 10 or 20, what I'm going to do is I'm going to build a variable to feed into this multiplier. And the variable that I'm going to use is I'm going to go to the variables tab, and rather than building a local variable, I want to build a global variable, so something that other objects and state machines can talk to, because I'm going to build a speed variable and feed that into the multiplier, and that's something that, based on collecting power-ups or based on managing other resources, I might be able to increase or decrease my speed. So I'll go to global variables, and I'm going to create a player speed variable, okay, and make sure that's a float. And I had already created this, so I'll just borrow this one that I've already created called player speed, and I've set the default value to 5. So I'll close that. I'll go back to my state, and in the multiplier field, rather than using the value of 1, I'm going to toggle this button over to the right, which allows me to feed in a variable. So now I'm using the global player speed variable. I set the default to 5 just to get some user input, or to get some basic speed going, and that looks pretty good. So currently I have this real basic setup where the camera is fixed, and that may work. That may do exactly what I want for this level, but I also may want the camera to kind of look at the sphere as it moves around. So there's a couple different methods that we can control the camera. The first method is borrowing a couple of scripts, or one of the scripts from Unity. There's a component camera control, and there's a list of scripts here that we can use, and if you don't have these scripts available, you simply need to go to Assets, Import Package, and make sure that you import the scripts package. Once you do that, you'll have access to these same components. What I'm going to do is I'm going to select the camera, and I'm going to assign a script to this camera. And I'll go to Components, Camera Control, and I'll do a real simple smooth look at script. Now we could build this functionality directly in Playmaker, and in fact we're going to end up modifying some of these scripts or rebuilding them completely in Playmaker, but I just wanted to show you that Unity provides a couple of scripts that can be very valuable. So now that I've added the smooth look at script to my camera object, I have this smooth look at script component. It's looking for a target, and so what I'm going to do is find the player character and click and drag and load that in as the target here. Now when I hit the play button, that script is going to cause the camera to constantly track the player and look at it, so you can see that camera kind of moves around. Now we do end up in this situation where, because the perspective of the camera might change, the controls start to seem a little counterintuitive, because as the camera rotates to the left to follow the character, the right and left, forward and backwards keys really don't make any sense anymore, because because it's changing the perspective and the relative view relative to the world space. And so that's something that we might want to correct for. I just wanted to make you aware of the options under the camera controls. Now we'll leverage this mouse orbit and a couple of other scripts as well. In fact, let me go and temporarily turn off the smooth look at script. So the script is still attached, but it's not being used. With the camera selected, I can go to Components, Camera Control, and I could do a mouse orbit. And the mouse orbit script is looking for similar information. It needs a target, in which case I'll use the player. We're going to run into the same problem here. This is some interesting input. It takes the camera, it follows the player, or whatever object we use as a target, and now I have a mouse look set up. So as I roll my mouse around, I'm orbiting my target object, and I can press the forward key and move forward. I can move left and right. Now the glitch in this setup comes that when I look in a different direction, now if I press the forward key, I'm still going to move relative to I'm going to move relative to the world space, okay, not the camera space. And so what I'm going to do is I'm going to build some simple functionality that allows me to capture the camera direction and apply force based on the camera direction. Okay, so I'm going to jump out of there. Now with the camera selected, I just want to point out that I have the mouse orbit script, and I do have some components here, that some variables that I can modify, the distance and the XY speed and some of the limits, and that's based on the user input here of being able to orbit. So if I wanted to change that, if I wanted to back a little bit further away, I could use this target distance, or the distance variable, and kind of back that off and make that 15 or 20, then the camera will be further away. What I want to do is I want to capture the direction of the camera and use that as the direction that I apply the force to that. And I could do this in a couple of different places, but to me it's going to make sense to do this on the character, on the player character under the player control. So what I want to do is I'm looking for a command called transform direction, and I believe that's under the, you guessed it, transform menu. And I'm looking for a transform direction command, and what this is going to do, I'll just double click and add this to the player. Now I'm going to move this up. Everything so far on my player control is working as intended, and so what I'm going to do is I move this transform direction, and we'll explore this in just a moment. I'm going to take this get access vector, that's the user input, I'm going to collapse that, and I'm going to collapse the add force for now to give me a little bit, you know, to kind of clean up my state actions here. So what I'm looking at here is the transform direction, and what this will do is it'll take the current direction of an object, its forward direction or its z-axis, and translate that to a world space. So it'll take the local direction of an object, okay, and in the case of the camera, it could be pointing in any given direction and translate that to a world space. And so what I'm going to do here is I'm going to go to variables, and I'm going to create a new variable. It's got to be a vector 3, because if I look at the transform direction, it wants to store the results of this in a vector 3. Okay, so I'm going to go to variables, I'm going to go to vector 3, and I'm going to call this camera direction, and I'll add that variable. I'll go back to state, and I'll store the results of this in camera direction, and I'll make sure that I do that every frame. Now, we're getting the transform or the forward direction of a game object. We don't want to use owner, okay, because we don't care what the direction of the player character is. And so what I'm going to do is I'm going to toggle this drop down. I want to specify a game object. The game object that I want to get the direction for is the camera, okay? So if I hit the play button and I look around, I'm hoping to get the forward direction of the main camera, and I'm hoping to see some results change down here. And I'm not seeing that. So let me jump back in here, and let me add a value to the Z direction, or the forward direction that I want to capture. And I'll hit the play button, and now as I roll the mouse around, you can see that that store result has changed, okay? And I'll just try to leave this in a position, and I'm actually going to leave this simulation running, and I'm just going to point out something. That as I bump up the value of 1, watch the results here of the store results. Watch what happens to these values. If I take 1 and I double it, I'll just double it, it's bumping up the values down here. I'll multiply this by 3, by 4, and you can see that that's proportionally increasing these values down here. So I'm just going to bump up the Z direction to 20 for now, just to kind of demonstrate this, to get some higher values in here. When I go back and hit the play button, actually it's gonna wipe out that value and set it back to 1, because I kept that simulation running. But I do want to point out that it's capturing the X, Y, and Z coordinate and figuring that as a direction for the camera. Okay, so I'm moving that around and I'm capturing the direction of the camera. Now I want to translate that to the force that I'm applying to my sphere. And I want to ignore the Y value of this, okay? And well, for now, I'm not going to ignore the Y, and I'll show you a little glitch that happens. I'm going to bump the Z value up to 20, and we can think of this kind of like the force that will end up pushing our player around. And I'm going to modify this a little bit so that when I go to add force, I'm going to change this temporarily from the player movement vector 3 to the camera direction vector 3. Now what's going to happen, because it's constantly getting the camera direction, we're constantly getting results for the camera direction, it's going to immediately start applying force based on the camera direction. So when I hit the play button, without any user input, I'm starting to move around. But you'll notice that I'm moving in the direction of my camera. Now one of the glitches here is that if I get up under, let me bump up the value. Let me go back here. Let me bump this value up to something a little bit more dramatic, like, let's say 80. And I'll hit the play button. we're going to encounter a glitch that if we get up underneath our player object, we can actually fly and lift it off the ground. So that's the Y value. Okay, and that can be kind of a cool mechanic, and maybe we'll incorporate that into a power-up. But what's happening is that we're capturing all three coordinates from the vector 3, but we're only interested in the x, z, because we just want to push the ball around, or the marble around, in the xz space. And so we'll do just a little simple quick correction for that here in just a moment. But what I'm going to do is I'm going to leave my camera direction mapped, and again, that's just, there's not very useful user input here, because again, it's just kind of, it's not tracking this on mouse click or using the AWSD keys. It's just kind of pushing this thing around, but we'll change that in a moment. What I want to do is I want to peel apart this vector 3 coordinate system. Okay, so I'm going to keep this value very high for now. And what I'm going to do is I'm going to go into the vector 3 drop-down menu, and I want to do a get vector 3 xyz. I'll just double-click, and I'm going to move this up under the transform direction so we can see how this is going to work a little bit more clearly. And I'll just kind of collapse add force for now. I don't really want to bother with that. So we're getting the direction of the camera. We're storing that in the camera direction, and we get these results down here in this vector 3. But I don't want to apply force based on the vector 3, because if I go down here and add force, we saw what that does. If we apply it based on the vector 3 direction, we're applying it against the x, the y, and the z. And really what I'm interested in for now is the x and the z. And what we can do is we can peel apart this vector 3 component that we're storing, this camera direction, and feed it into add force x and z, but we got to get those values, okay? And that's what this get vector 3 xyz does. It takes a vector 3 variable, so we'll borrow the camera direction, okay? So whatever the value of camera direction is, and we want to do this every frame, and we'll store the x and the z. We'll store the x and the z into two different variables. So let's go make those variables. I'm going to go to variables. These are going to be two float variables. I'm going to call this x. I'll call this x direction. And I'll call the next one z direction. Okay, so we have an x and a z. I'm going to go back to my state, and so we're pulling apart this vector 3 coordinate, and I want to store the x in the x direction, and I want to store the z in the z direction, and we'll do this every frame. So we're basically splitting it apart, but we're also ignoring the y for now. And instead of then adding force to the camera direction, we'll apply this to the x value to the x direction, and the z value to the z direction. Okay, so now when I hit the play button, okay, we're kind of getting the same results when we drive our sphere around, okay, but we can't go up and push underneath our sphere to cause that thing to float again, so it falls to the ground. Okay, so we've kind of solved a little bit of a glitch that we might have discovered otherwise. So again, just a real quick recap. On the main camera, I've added a mouse orbit that gives me orbit control. From there, I went into the player object and I built this state based on a couple of different actions. I used a transform direction to get the camera direction, and we stored that into a vector 3 variable. We then pulled apart that vector 3 so that we could access just the x and just the z values, okay? And then we're adding force. We can ignore this get access vector. That's using the user input, but we're temporarily not using that. And then we're adding force based on the x direction and the z direction. In the next presentation, we'll iron this out to translate this to user input rather than just straight mouse direction and have it constantly on. We'll have it look in a specific direction and then map this back to the get access vector that the user is putting into the equation. But we'll do that in the next presentation.